Hello ladies and gentlemen, welcome back. Today we'll be looking at the operations of functions and composite functions. We'll be forming the sum, difference, product, and quotient of two functions, and we'll be forming the composite and finding the domain. Let's get started. Alright, so as you can see here, they can ask you two different ways to do your operation. They can say f plus g of x. Well, that's actually the same as f of x plus g of x. Okay, and likewise for the difference, they can ask you separately. For the product, ask you separately, and for the quotient, they can ask you separately. Now, notice that this is very important. G of x cannot be 0. Okay, whatever your denominator is, it cannot be 0. So we always test that to see where this is not possible. Okay, let's go ahead and see what we can do. Alright, let's go ahead and find our four operations using f of x equal to 3x plus 4 and g of x equals to 2x minus 3. So, here we'll be doing f plus g of x. So, I'm going to grab my f of x, which is 3x plus 4, and I'll be adding it to this. Now you could go ahead and use parentheses, but since I'm adding, the parentheses don't actually do anything, and I can actually just go ahead and start collecting my like terms. Okay, here I'll have 5x plus 1, and that's my answer. I can't simplify it anymore. Notice that my domain, it's not hindered by anything. So here my domain is all real numbers. Let's go ahead and find the difference. So here I'll be subtracting my f of x, 3x plus 4, from g of x. Now here my parentheses is important because my minus sign does mean something. It means that everything in here, if I'm just going to go ahead and collect like terms, I need to go ahead and switch the sign for everybody in here. So that's not a plus 2 anymore. Okay, that's a minus 2. And this is a plus 3. Okay, another way to see that is by distributing that negative 1 that's here. Distribute, distribute. Okay, so that becomes minus 2 and plus 3. Okay, let me go ahead and clear this up. Either way, we have minus 2x plus 3. Go ahead and collect your like terms. I have just x and plus 7. So x plus 7 is my answer here. Let's go ahead and find the product of these two functions. F times g of x, okay, which is, I'll move here so I have more space, which is 3x plus 4 times 2x minus 3. Okay, here I'll be distributing, okay, or foiling, same thing. 3x times 2x, 6x squared minus 9x, now my 4, plus 8x, and now with the last one minus 12. I only have this to combine, so this is minus x minus 12. Okay, and here this is just quadratic, so it's a parabola we graphed it. The domain is not hindered by anything, so my domain is all real numbers. So the last one is to look at my quotient for these two functions. So I have f divided by g of x. So, okay, as it implied earlier, it's just f of x over g of x. But remember, we have to test this domain. Test where this is equal to 0. Okay, so I'll grab my top one, 3x plus 4 over 2x minus 3. If I can simplify, I simplify, but there's nothing for me to do, so I go straight into testing my domain. Remember, you want to see where this is equal to 0, because that's not going to be one of your answers. So where you want to find out where 2x minus 3 is equal to 0. Okay, that's our bad zone. We don't want it. So move this over. 2x is equal to 3. Divide by 2 on both sides, and x is equal to 3 over 2. So this lets you know that your domain, okay, all the x's except where x is equal to 3 over 2. Okay, that is not one of your answers. Every other number is part of your domain except for 3 over 2. Okay, let's try another one out. Alright, let's try one that looks a little bit harder. Here we'll be adding these two functions, so I'll be doing f of x plus g of x. Here I have the square root of x plus 2 plus the square root of 3 minus x. Now, in order for me to add these two radicals together, they would actually have to be exactly the same on the inside. And since they're not, there's actually nothing I can do. I'm actually done right here. All I have to do is set my domain. My domain is going to be set by, well, each individual restriction. So here, remember that x plus 2, okay, anything that's inside the square root has to be greater than or equal to 0. Okay, you can't have any negatives in here or you get complex imaginary numbers. So I'm going to subtract 2, and I know that my domain for this one is where all my x's are greater than or equal to negative 2. Likewise, I'll look at my domain here. 3 minus x, this has to be greater than or equal to 0. Subtract 3 from both sides, and I get negative x is greater than or equal to negative 3. That's a negative x, so I'll divide by negative 1, and by doing that, I switch my sign around, and I get 3. So here, my domain is the combination of these two restrictions. So overall, my x has to be less than or equal to 3, but it has to be greater than or equal to negative 2. So this is my domain for the function. All right, let's try subtracting. All right, here we'll be subtracting. Likewise, I just have the square root of x plus 2 minus the square root of 3 minus x. And same rules apply. I cannot combine these. They don't have the same radicand, so there's nothing I can do. And likewise, my domain is actually going to be the same. It's set up by the restriction of these two and then combined. So just like before, my x has to be less than or equal to 3, and it has to be greater than or equal to negative 2. So my x's can only be chosen between these two numbers. Let's try to multiply. Alright, here we're multiplying, and so we'll have the square root of x plus 2 times the square root of 3 minus x. Okay. Now, when you are multiplying radicals and they have the same root, you can go ahead and just combine them. You could do this, the square root of, okay, x plus 2 times 3 minus x. Okay, they have the same index, okay. I know we don't write it, but it's supposed to have a little 2 there. Okay, since they're both the same, we can just go ahead and combine the two things that are on the inside, and that's it. Now, most people will actually just stop right here. If your teacher wants you to distribute this, just go ahead and distribute what's on the inside. You'll get a quadratic formula on the inside, but most likely you'll just stop here. Looking at our domain, these two things, okay, they need to stay positive. So this, you don't want it to be a negative, and likewise you don't want this to be a negative. So it's the same restrictions as before. You want this to be greater than 0, and you want this to be greater than 0. Since they're the same as before, our domain is actually the same as before. Our x is between -2 and +3. Now let's go ahead and divide. Alright, to divide is going to take just a little bit more work. Let's look at how we have. We have f of x over g of x. So square root of x plus 2 over the square root of 3 minus x. Now, you should know by now that we don't leave square roots in the denominators. We get rid of them. So in order to get rid of this square root, we're going to go ahead and multiply by that same square root. 3 minus x here. Why? Because a square root times the same square root cancels out that square root, and you just are left with what's on the inside. So here, my denominator is easier to get. You just write it again, but without the square root symbol. 3 minus x. For your numerator, look at what you have. You have square root of x plus 2 times the square root of 3 minus x. You've done that before, and you should remember that you just combine what's on the inside. So the square root of x plus 2 times 3 minus x. And there. Now, that's it. That's all you have to do. Now you think about your domain. My domain is almost like before. It was -2. Okay, it was between -2 and 3. Now if you remember, when we did this one, okay, this is what we had before. When we did this one, we said 3 minus x, we wanted it to be greater than or equal to 0. But here, since this is the denominator, you don't want it to be equal to 0. You can't have 0 in the denominator. You want it to be greater than 0. So what does that do here? It takes away that equal to sign, and that's it. Remember, you don't want 0 as your denominator, so that's why we took away the equal to sign. Okay, we don't want it in this case. And there, that's it for this one. Now it's your turn. Alright, go ahead and pause the video, try these out, and do the 4 operations. I'll show you the answers in 3, 2, 1. Here are your answers. Pay close attention to the domains, and I hope you got them right. Alright, so here we'll be looking at composite functions, and here all you're saying is that f is composed of g of x. So you're saying that f is made up of g. So for example, if you had, let's say, f of x is equal to x squared, you've seen that, and let's say that g of x is equal to x plus 1, and you wanted to find f composed of g, then all you have to do is put g inside of f. So instead of x squared, it's this x plus 1 squared. Okay, and that's it. Let's look at more examples. Alright, here I'm giving you that f of x is equal to 2x squared minus 3 and g of x is equal to 4x. So here, the first one I want to find is f composed of g, and I want to find that when x is 1. So this means that I have f of g of 1. Okay, that's what I'm trying to find. Now, there's 2 ways to do it. Whatever you choose is up to you. What you can do is actually find out how much this is first. G of 1. You want to find out what's on the inside first. So g of 1, I can go ahead and take it and say, alright, well g of 1 is 4 times 1. That's just 4. And now that I know what this is, I'm actually just trying to find out f of 4. And I can go ahead and put that inside. And f of 4 is 2 times 4 squared minus 3. That's 2 times 16 minus 3, 32 minus 3, and that's 29. Okay, so you can do it individually, or of course you can do it, and I'll do the same one real quick. Actually, I'll do the next one the other way, or you can do this. Let's say they gave you g of f of 1. Okay, notice that your x is still 1, but the order is different. The order is important. It tells you who goes where. So this time I'm finding this out. Okay, this is the other way you can do it, and you'll get the same answer. So I'm finding this out. I'm finding out g. So I start writing down g, 4, but that's not the regular x. That x is whatever f is. F is 2, and that's not a regular x, that's a 1. So 1 squared minus 3, close parentheses. So look, I have g, and inside is my f. Or you can work it out individually, like before. You find out how much f of 1 is, and then put it inside of g. So if I do it like this, I get 4 times 1 squared is 1, 1 times 2 is 2, so 2 minus 3. I get 4 times negative 1 and negative 4. Okay? Whatever way you choose to do it is up to you. What about if they give you something like this? If they give you f composed of f of negative 2. Okay, you can do that. You can go ahead and compose functions with that same function, and that's fine. That just means that you have f of negative 2. So let's find out, let's do this one individually. Let's find out how much f of negative 2 is. So for that first one, I have f of negative 2 is equal to 2, negative 2 squared minus 3. Negative 2 squared is 4, so 2 times 4 minus 3, 8 minus 3, okay, and that's 5. Now we just put this answer inside f again. So I put a 5 in here. I want to find out f of 5. And that's 2 times 5 squared minus 3, 2 times 25 minus 3, 50 minus 3, and 47. So here my final answer is 47. Now that you know that you can compose functions of the same function, our last one is going to be g composed of g when x is negative 1. Okay, let's do this one the other way. So this actually says 4 times another 4, and this time x is negative 1. Okay. So here I have the inside g, and this is the outside. So this just says 4 times negative 4, that's negative 16. Okay, there. Like I said, whichever way you choose to do it is up to you, however you feel more comfortable. Like that, you'll always get them right. Right. Here are 2 composite functions. Go ahead and find each composition, and I'll give you the answers in 3, 2, 1. Here are your answers. I hope you got them right. Alright, that's it for today. Thank you for joining us. Until next time.